Thanks, Adam. Hello, everybody. My name is Chris Schneider. I'm an applications engineer here at 3D Systems. Today, for our Tuesday product spotlight, I'll be talking about the Helix Sketch in DesignX, a little bit of how to set it up and use it, as well as some examples where you might find this useful. The Helix Sketch is a very distinct feature. When you see it in a part, you will recognize it as a helix or a partial helix. There are two types of helix that you may run into. There is a variable helix or a constant helix. Helix can vary in their pitch, which is the size of between each revolution, as well as their radius, so they can expand into funnels or screws and go from large to small. So very common applications where you would use a helix sketch are with augers or screws or threads. But there are also some drills and spring applications that can be a little more complex if the springs are compressed or if there's a double helix of sorts. And in some cases, there are even decorations that have helical shapes where you're being asked to model this. The helix sketch can be used to make your life a little bit easier to describe more free-flowing geometry as a helical shape rather than just an arc or a line. There are a couple things that make Helix unique as when it comes to 3D splines. So they all have the same parameters, but they can be different to describe the shapes. So here are two examples of a helix that can be made in DesignX. We have our more standard helix, which it just progresses in one linear direction. And then we have a variable helix that can be expanded into some more complex and interesting shapes. So they're all the same. They start with the same basic parameters and then they are adjusted. So all helixes have a starting point. This is where the helix begins and progresses in a certain direction. The vector is the direction that the helix progresses in. This means that we either go counterclockwise or clockwise around this vector from the starting point. Then once we have those two parameters defined, we have a couple more that we define afterwards, such as the height, which is the overall top to bottom distance that the helix goes across. This is independent of the other parameters, but also impact them. So the radius is how far the curve or the point is from the center axis. So this is the radius of a circle. This is the same thing for a helix, except it doesn't come back to the same point once you travel all the way around the circle. The pitch is the height between one revolution. This means we start at one point, go all the way around the vector, and we come back to the same xy place. We're at a different z height. This is the pitch. Finally, we have the revolution, which is the number of times the helix goes around the axis from the top to the bottom of the height. So all these parameters are dependent on each other and can be manipulated. So if we manipulate some of these parameters, others will be affected. That's just something to keep in mind when we're starting to define the parameters of a helix. So we're going to jump right into the software. We're going to talk about this little cap here today. So if we jump to our finished model, here's what we'll be going through today. We have our raw scan here, and we have this thread on the inside of our cap. So if we were asked to model this part, this is an ideal place where we would want to use the helix tool. So jumping over to the beginning of this model, we can get into a little bit of the details of how to do this. So starting off, we've set this file up so it works pretty nicely for us. So we've aligned this scan to the world. So we have our XY plane here as our base, our front plane, and we've just mated that to the bottom of this cap. We've also scanned directly into DesignX and touched up this scan, so we have a very nice clean mesh to start with. That's not always a requirement, and even with a nice clean mesh, we have a couple issues. So we have some holes here where the scanner wasn't able to capture this information. The other thing we have to worry about is that mesh data is not always perfect. So even though we've cleaned up this part, we still have a couple issues. So we can see there's some bumps in the model. There's some more texture on the sidewall here. So I know I scanned this cap and it is made through an injection molded manufacturing method. So this part could have been bent or more worn. So these are some things we have to keep in mind when we're approaching the modeling process on a cap. So the first thing we're going to do here is set up our vector. So I've already gone ahead and done this. So the vector is going to be matching the center of this cap. So if this cap was revolved around to be created, we've aligned them to the world to each other. So this specific vector I've extracted as my z-axis, which may be different than the revolving axis of my cap. This is because I know scan data isn't perfect and I want to model perfect geometry. So this is the approach we're going to work with today. So we have our vector as one of our starting geometries. We need one more additional shape, and that's going to be the starting point. So what we're going to do is we're going to hop into our sketch here. So just right-clicking on this top plane right here and opening the contextual menus. I'm going to hop into the 2D mesh sketch setup. So the 2D mesh sketch setup here has a preview of an intersection between our base top plane and our 3D scan. So this solid teal line will be the cross-section that is represented in our sketch. So we're going to go ahead and hop in here and we're going to go take a look. So we're going to rotate this guy around and we're going to focus on one of these teeth. So if we hide our mesh real quick, we can see that our 2D polyline here has two teeth on the right-hand side and then one teeth on the left-hand side. So we're going to focus on this top right-hand tooth right here, because what we're going to do is we're going to take this profile and use it in our helix sketch to revolve it around, to create our thread to describe this. So we'll go ahead and just extract the top, and then we'll go ahead and extract the bottom. And we can kind of see that this is not a perfect triangle. So if we were interested in generating a standardized thread or another accepted thing that goes into an assembly, or we always know that the company that makes this part always uses the same thread size, we can construct sketch geometry here to further constrain these shapes to be ideal, right? So we'll just go in here and make a triangle real quick. What I mean by that is we can make, say, a center line here and take an angle measurement between this center line and generate an ideal degree where we want this tooth to be. So we're not going to go into that today, but here's the point where you would go in and start constructing this shape to be more standardized, but this is where you would do it. So the main point to do at this step, though, to construct the helix is one, make the shape that will end up sweeping, so this will be the thread shape, as well as make the point where we're going to start our helix. So on this part, we have our starting point slightly off the end of our thread where we cross-sectioned it, and this could have been maybe there was a fillet in the original drawing, or this part was worn down, right? So instead of having to make that 3D reference point, we're just going to extract and take this center point as our starting point. So we'll come out of our sketch here. We'll go turn our mesh back on and see what we have. So right now we have our centerline vector, which is going to be where we're going to construct our helix from. We have our 2D mesh sketch, so we're building up our history tree of things on the left-hand side in our model manager. And then we're going to go into our helix and start talking about that command specifically. So what I've done today is I pulled the helix command out and put it on my top ribbon right here. So this is very easy to do to customize your ribbon. All you have to do is right-click on your ribbon, open up the Customize menu, and start adding and subtracting tools. So this is very common if you're using tools very often, or you prefer certain tool sets to the ones that we've offered you, which we've kind of picked and choose which we think are the best ones. You can definitely go in and customize it for you and show what you want to see. So this is very easy to use. Otherwise, if you haven't done this already, we have all of our menus and tools already outlined for you. So we can just go to Menu, Insert, Modeling Feature, and then we have our helix curve here as well. So it's the same tool, just two different ways to get there. So in the dialog for the helix tool, we have some of the parameters that we outlined before. We have our axis and our starting point. And then we have these two options which are consistent and variable. So these two options talk about the pitch of a helix, which is how tall a revolution is on a helix. And when we encounter more complex geometry or screws or things that change over the distance, we can use the variable fillet to model those changes in pitch. But for this example, we're going to walk through the constant fillet. And then in the follow-up material, there'll be an example of a variable fillet. So to start off with, we just pick our axis. So we can just select our axis either in the tree or in the graphics viewport. And then we pick our starting point. So here we can pick our 3D reference points, or we pick this center point we've done in our sketch, and then we have a preview of our helix. So there's a couple more options here that I want to point out before we move forward. Is that in the bottom side, we say what direction we want to go in. So this is if we have right-handed screws or left-handed screws, we have the option to change the direction that this helix progresses in, right? We also have this option to extend in an opposite direction. So in a case like this, where we haven't started at the beginning, or there might be some other shapes, other way around the helix, we just check this option and then it continues in the opposite direction. So there is also this plot mesh section as a guide curve. So this is very handy for if we have screws that have a different radius, right? So we start off large and we go smaller, or we go smaller and we go larger, so like a funnel sort of thing. The bottom is going to represent this information. So if you're familiar with the variable fillet, this is the same sort of dialogue, as well as the 2D mesh sketch, right? So we have this preview of a cross-section of our mesh with this reference polyline, which we can start constructing our helix from as a guide. So we can see we started our 2D mesh sketch with these two threads, and this cross-section also shows me this information. So if this thread got bigger or smaller with the radius, this is a visual representation of that as well. So this plot is set up where we have the height along the x-axis, and then we have the radius along the y-axis. So we have this little key at the bottom. So it starts at 0. That's what this center line is for, or this darker gray line is for. And then we have these numbers at the top, which can be helpful. And then we can resize the bounds by just zooming in and out. So the graphics view shows me the live update of what we're doing. So we have this spiral, or this helix line, which is our preview of what's going on. And then we have this straight line at the bottom, which is also the preview of what's going on. So we're just displaying you the same information two different ways. So the parameters of how to change this are pretty easy to control. So we can just click and drag these nodes here, right? And since I'm changing the radius here along the y direction, you can see that the sketch lines in the viewport go in and outside the starting point. So that's a very easy way to visually check to see how you're doing. So this is where the 2D profile here is nice, where if we do see a kind of funnel shape here, we can use the top of the teeth here as a guide, right? So turning our mesh back on. Looking at nice. So here we have some other parameters that we talked about in our setup tab. So we have our height, which is the top to bottom height of the helix. We have our radius, so this will be the radius at this point. We have the pitch, which is the top to bottom height of one time around, right? So if we look at it here sideways, we have the height of everything, which is the start to the bottom, right? So this other dot right here. Hide this guy, so top to bottom height, and then we have the height of the height of one revolution, which is the pitch, which is the height from here to here. And then we have one more option here, which is the actual revolution. So since these parameters are all dependent on each other, if I go to change one thing, some of the other things will change. So if I click on this box under revolution, the pitch becomes red. This means that if I change the revolution, the pitch is going to change. That's because I'm not changing the height. So all of these are dependent on each other, and the red highlight is your visual indicator of what is going to change and depend on what you're moving around. So there's a couple ways to actually generate and extract this helix shape with the anticipation that the part might not be perfect. So first you have the 2D sketch, which is the pink polyline here. And then you also can just click and manipulate these numbers themselves. So from looking at this part, I know that maybe I need a little bit more height along here, so that's just extending this line out. And I know that the pitch is going to be a little bit bigger as well, so we can just go in and pick a number here. So if I hover over these numbers, I have these up and down arrows, which will let me move up and down by an increment, or I can just click in the box and type in the number that I want. So we look pretty close. If we look in the viewport, we can see that the helix curve is on the edge of this tooth here, which is what we're looking for. And we're a little bit beyond here, which is okay, because it's always nice to have extra material that we can model away from rather than trying to add it at the end. So once we have all of our parameters good, we can always just say okay here. And now we have this 3D helix curve in our file. On the left-hand side, we now just have this helix curve feature. And this behaves very similar to a 3D sketch, right? So we can convert this to a 3D sketch if we want to make spline nodes and move things around. But while it's a helix curve, it is a perfect mathematical shape as a helix. So the last step we need to do to actually make this modeling feature is to swoop it around. So all we have to do is go up to the top, select our sweep tool, select our profile, which is that first sketch we made, select our path, which is our helix path here. Here we go, helix path. And then let's try this one more time here. Profile is our sketch, helix path is our helix. Here we go. And then we just say OK. And then now if we hide our mesh, we have our helix tooth right here. And now is a good time to check our accuracy analyzer, see how well we did. And this is a good point to check to see if maybe we need to go back and adjust our pitch and see if our height's good and all that kind of thing. So we can start to see how well we did here and just reduce our accuracy analyzer until we find our correct modeling tolerance. But this part under 5 millimeters or 0.05 millimeters is good, so we're probably just going to leave it here. So modeling the rest of this file will take us into the completed part, and then you have everything that you kind of need. So this file has the same thing, except we added just a little bit of variability to the last bit of the sketch, so the helix goes right into the sidewall. And that's all through the same dialog without having to add a second helix or anything like that. So that's the demonstration today in the software. So if we hop back to our PowerPoint, we have just one or two more things to cover. Here we go. So the additional resources we're going to provide today, or if you have any more questions, please feel free to visit our website. We have all of documentation and more information, all of our software, hardware, and other solutions that we offer. If you are interested in looking more into DesignX from a sales point of view, you can email our sales team directly at gmagic.sales.americas@3dsystems.com. If you do not have DesignX yet and you want to play around with the file we'll send you, you can download our trial and talk to our technical support team at gettingstarted.com or gettingstarted.geomagic.com. And as I said, we will forward you these files at a later date. So that's everything on the software side. Adam, back to you.
All right, well, thank you, Chris. So yeah, this brings us to the end of the Geomagic Product Spotlight webinar on DesignX. Please be on the lookout for invitations to future DesignX product spotlights from 3D Systems. As I said earlier, in the coming days, each of you will receive an email with a link to the recorded version of this webinar, some useful links regarding DesignX, as well as the files that Chris used during today's demonstration. For those of you that have asked questions during the webinar, we'll be sure to follow up with you to answer those questions in a timely manner. Thank you again very much for joining us, and have a good rest of your day.